Hello my dear students, how are you all? Welcome back to the channel. Today I am here with part 4 of your chapter Continuity and Differentiability. Okay, now what if I tell you this is the most important session of this entire chapter? How come, sir, we have covered almost everything in the chapter, then how come this is the most important topic? Because see here, today we are going to discuss parametric form and second order derivative. Today we are going to discuss parametric form and second order derivative. Now why this is important? Because of course whatever you have learnt is going to be useful, but questions whether it is in boards or KCET or even for JEE are asked on the second order derivative. If you see those questions, they are coming from this. Okay, whether they are using the definitions, the formulas given in the previous sessions, but these two topics plays a very big role, including one more topic which is there already discussed with you, implicit functions. So if you talk about questions coming from basically 5 to 6 questions coming from this chapter in your KCET, they're going to utilize questions on implicit function, parametric form and second order derivative. Okay, second order derivative, very important. Alright, so I am going to take total of today 10 questions. Today I am going to solve total of 10 questions. Okay, in that we'll use all these three. Second order derivative, implicit function and the parametric form. Clear? I want to explain you which form, why it is called parametric form, okay, and how do we find second order derivative. Alright, so I'm telling you very important for boards and for CET. So if you want to actually score that 5 marks, that 6 marks from this particular chapter, not AOD, only this chapter 5 marks can be, actually simply you can obtain that by solving these questions, very important. Okay, if you do that, you'll be of course among the toppers next year, and you can join your elite group of your seniors who got outstanding result this year. When I say outstanding, I means gonna join CS, they'll get CS stream in top colleges across Karnataka. Okay, you can be among them if you are actually able to solve this 5 marks from this chapter. If you can get this 5 marks, you'll be closer to that goal of yours, to getting a very good college for your engineering. Okay, so this is clear. Let's begin. Now, so in the session today, I'm going to start with what? I'm going to start with parametric form. Parametric form, have a look. So whenever the given function, usually what we do, we find derivative like this y dash. Okay, we write this as dy by dx. So the given function y will not be in terms of the variable x. The given function y will not be directly in the terms of the variable x. It can be given in the form of, let's say, theta, if it is a trigonometric function, given in terms of a variable t or something like that. Okay, or we can have other variable also. So whenever we have those cases where a parameter theta or t or something else is involved, and we are asked to find what? Derivative of that. Then what you do actually, you find it like this. Have a look. dy by dt, and this will be actually dx by dt. There's a mistake. Same way, even x will be given in the form of the same parameter, either theta or t. So instead of, when you are asked to find dy by dx, right, you'll have to use this approach, that divide dy, basically differentiate dy by dt first, and then you move on to dividing that part with dx by dt. So you have to find the derivative of both the functions y and x in terms of their parameter, and then you're gonna divide them. Okay, check here, same thing, it's dx by dt, not dy by dt. When you do that, that is going to be a result based upon derivative of the functions in the parametric form. Okay, see, so x is a function in t, y is a function in again t, x is ft, y is gt. Okay, so what is going to be the answer? Have a look. Your dy by dx over here will become what? G dash t upon f dash t. That's what, g dash t upon f dash t. Okay, so we'll use this with the help of a question also. We'll see, I'll explain you with the help of the question also. Now sometime they can also ask you, so they can give you, like if I take an example over here, let me take an example over here. They can ask you that y is sine theta, okay, and x is cos theta. Find me dy by dx. Okay, then what you do? Differentiate sine with respect to, again, theta. You will have cos over there. Derivative of sine is what? Derivative of sine is cos theta. Okay, and divide that by derivative of cos, which is what? Minus sin theta. Your answer is what? Minus cot theta. So this is a derivative in the form of parameters theta. Okay, but I can change that and differentiate a given function with respect to another function. With respect to another function. For example, I can differentiate sine with respect to x square. Let's say y is given as sine t and x is given as t square. They can ask you to differentiate y with respect to the x also. Y with respect to x as well. In this case, same approach will be there. We'll have the same approach. dy by dx will have the same approach as dy by dt upon dx by dt. But you can see here the functions are different, isn't it? The function is sine, over here trigonometric function, here we have polynomial function. So they can ask you to differentiate a given function with respect to another function. So I have taken a question on this also. I'll explain it to you with the help of that. You can just tell me over here what is the answer. Okay, in the comment section right now put what is the answer for this one. Right now comment below what is the answer for this example. Write the answer as example and whatever answer you got, give me that in the comment section right now. All of you who are watching this video, give me a comment example what is the answer. Take a pause, solve it, differentiate y with t, okay, and x with also t, and give me the final result, and write here in the comment section example and what is the answer coming your way. Okay, the answer that you're getting, not the answer word, whatever result you got that you're going to put it over here. Okay, check here. So same approach, dy by dx equals to dy by dx upon dz by dx, where the y and z are different functions. All right, let's move on. Now we're going to solve the first question based upon this parametric form. Okay, so basically what are they asking? Find derivative where x and y is given in the terms of the parameter t. T is the parameter here, right? T is our parameter here, right? So how do you solve it? Same approach, sir. I need to find dy by dx, so I have to get what? Dy by dt divided by dx by dt. What I can do is simply do that in the form of fractions. So I can find the derivatives of dy and dx individually and then divide it at the last. Both method is correct, yes or no? Yes. So let's do that. Let's find the first one, which is dy by dt. Over here, derivative of a sin t will become a is a constant, sin t will be cos t. Sin t will be cos t. Is that right? That's end of my dy by dt. Moving on to dx by dt. So I'll take again same approach, dx by dt, derivative of this number. So a is a constant, keep it outside, a as it is. Now differentiate what is there in the bracket. Cos t becomes minus sin t, derivative of cos t is minus sin t. Derivative of cos t is minus sin t. Apart from that, we have now derivative of log. Derivative of log is what? 1 upon the number inside the log. 1 upon the number inside the log. So go here, plus 1 upon tan t by 2. Tan t by 2. Is it over now? Of course not. Use the chain rule. So you're going to differentiate. First you differentiated log. Next we'll move on to tan. So we get tan as sec square t by 2. Is it over now? Still we have t by 2 as a function, which is a polynomial function left. To differentiate t by 2 also, you'll have the value as 1 by 2. That's the final one. 1 by 2 is also there. I hope this is visible. This is 2, okay? 1 by 2 is the derivative of x by 2 or t by 2 in this case. Okay? Let me take some more space to write this. dx by dt. We have a over here. Alright? We write this as minus sin t. And now I'm going to start writing tan on everything in terms of sin and cos. Okay? Because we have something of dy by dt in terms of cos only. That's why I'm going to write everything in terms of sin and cos. So we have this number 1 by 2. You can see here 1 by 2. It means 2 is in the denominator. So write this 2 over here. What about tan? Tan t by 2 will become sin t by 2 divided by cos t by 2. Cos t by 2. Okay? And we have sec square. Sec square can be taken in the denominator as what? What? Cos square. Reciprocal, right? Cos square t by 2. I think that's over. That's it. Correct? Sec square becomes cos square in the denominator. We are using the reciprocal of sec. check this out, cos t by 2 and cos square will cancel one of the cos over here. Okay, so what is left now? Let me continue. So dx by dt, we have a times of minus sin t, and this will be plus 1 upon 2 sin cos. So simply sin 2 times of t by 2, right? And this 2 and 2 is cancelled. What I get? I get dx by dt equals to a times of minus sin t plus 1 upon sin t, right? 2 sin t by 2 cos t by 2. Formula is there, right? Sin 2 t by 2. Okay, half and 2 is cancelled. We get sin t over here. LCM if you take, it will be what? Minus sin square t plus 1 upon sin t, which is what? I get a cos square t. This is square, not 2. 1 second, I can write better. Yeah, this value here is cos square. Okay, this is a cos square t upon sin t. This is my dx by dt. What I want is derivative, right? You want derivative of this last step. So my dy by dx will become, from here, this is my first one, equation 1, and this is my equation number 2, equation 2. Okay, so from 1 and 2 you can see, differentiate and divide the derivatives. So what I get? A cos t divided by a square a cos square, yeah, a cos square t upon sin t. Okay, so we get a and a cancel, cos also that gets cancelled over here with cos square. I'm getting here sin will go up, so sin by cos. Answer is what, dear? Tan t. My final answer is tan t. Have a look. My final answer is tan t. So I hope all of you got this result. I hope all of you got the same result as tan t. Okay, please try to solve all the questions before I give you the answer. How can I do that? Pause the video and attempt from your side and see whether your approach is matching with my approach or not. Now I'm completely okay with you skipping some steps. Let's say I have written here 1, 2, 3, again here 5 steps. I've written a total of 8 steps over here. You can solve it in 4 steps, 2 steps, very good. But I am writing all the steps so that you know how the method is working. Okay, try to skip steps in the process. Reason is very simple. Skipping step means you can solve the question in your mind. It means it enables your ability to think and solve the problems. So please try to skip steps on purpose, especially for what? If you have a PEP in mind for CET. Okay, because in the CET you don't have time to solve all the questions in detail. Would you? No. So if you can do some steps, let's say for example this one, not required, sir. We can do this in our mind. Okay, here or this one also. Okay, this step we're gonna do, this step we're gonna do, but this one we don't have to do. In our mind we can do this, sir. This we're gonna do. Okay, and this step again we don't have to do, sir. This we can also do in our mind, sir. Okay, this also we can do in our mind, sir. And you can see even this step, let's say you want to do, you can do it over here, but that is enough. So basically our 8-step method becomes equal to 1 step, 2 step and 3 step method. So if you can do in the mind, 3 step is enough. First step, this you don't have to do. You know how, what is derivative of a sin t, a cos t. This step you have to do. Okay, and apart from that, move to this step. This you can do. Don't do this step. Okay, so you can do the calculation in your mind also over here, and likewise. Okay, so try to skip steps. It's going to help you only. Question number 1 is over. Question number 2 we'll move on to. All right. Now, so question number 1 was on basis of parametric form, or basically a derivative of a function with respect to another function. Right, derivative of a function. When another function is given, you're asked to differentiate with respect to that. Okay. Now second derivative, how do we deal with this, sir? Very simple. Derivative of first derivative is what? Second derivative. If you know this much is enough. Derivative of first derivative is second derivative. That's all. That's all. Sir, I know that already. Yes, that's all. There's nothing more. See here. This is a symbol for second derivative. D square y upon dx square. D square y upon dx square. Okay, and you can also write this as y2 or y double dash. All these are the symbols of second derivative. So check carefully here. Second derivative is given by derivative. This represents what? this represents here derivative of first derivative. This represents here first derivative. Okay, first derivative. And what is this? Derivative. So derivative of first derivative is called as second derivative. Okay, all right, this is it. Let's see with the help of a question. Let's see with the help of a question. So differentiate log. Now we are moving back to what? We are moving back to derivative of a function with respect to another function. Differentiate this function log with respect to tan inverse of x. Very difficult, you will see. Okay, let's take this as function y equals to log of 1 plus x square. Okay, and function x is, function x equals to function t equals to tan inverse of x. What I'm looking for? dy by dt. dy by dt. How come, sir? Because they are saying that differentiate this with respect to this one, this with respect to this one. Okay, so this is my function y, which is written in terms of the variable x. Okay, and the function t is also in the variable x only. Derivative of this will become what? Derivative of y with x upon derivative of t with x. Okay, let's do this. So dy by dx will be what? Derivative of log part. You will have 1 upon the same thing which is there in the log. So 1 plus x square. Right? That's how I differentiate the logarithms. And derivative of 1 plus x square will be what? Chain rule. 1 will be 0, x square will be 2x. For 1 will be 0, for x square will be 2x, the derivative. Okay? That's what dy by dx. Now I'm going to find what? dt by dx. So what I get? Have a look. So for dt by dx I'm getting here a derivative of tan inverse, right? So 1 upon 1 plus x square. Ratio of these two. Please check. dy by dt will become equal to what? 2x upon 1 plus x square upon 1 plus x square. Cancel. Answer is simply 2x. Answer is simply 2x. Option C is correct. Option C is correct. Now again I have written over here how many steps? 1, 2, 3, 4, 5, 6 steps. What you can do, what you need to write. So what steps you can skip in your mind, what you can do. So these steps you can again skip. Not required, not required. This mark doesn't mean that it is incorrect. It means that not required. Okay. This not required again. This one not required again. What about this one? Not required. Only this step is more than enough. Only one step question. So this is a one step question. See, you don't have to write any of this. You know derivative of this, right? You know the parametric form, how it's applied in your mind. Just write this part, differentiate this function. It will become 1 by x square with the derivative of x square in the chain rule. That is your numerator over here. Denominator will be what? 1 upon 1 plus x square. Divide that, answer is 2x. So this actually is a one step question. I have written all of that to explain you everything. But in your mind, you don't have to do all of this. Just simply do this step and your answer is done. If you know the formulas, if you know the approach of parametric form, that's more than enough. That's more than sufficient. Tell me, is this good enough for you or not? If you want a different approach for this, let me know again. What is a different approach? Let's say as a student, you might have developed some other type of methods to solve questions like this. Let me know how you go about that. Okay, so question number 2 is over. Okay, now question number 3. dy by dx if x equals to this and y equals to this. In this case, both functions, x is also in the parameter of m, y is also in the parameter of m. So here parameter is m. Alright, how do you find that? You are looking for dy by dx. Please check carefully here. What are they asking? dy by dx. They are asking us dy by dx. Sometimes they might ask you dx by dy also. That's why I said please check once again in the question what are they saying. They might ask you dx by dy also. Okay, then the approach will change, right? You have to reciprocate all of the result. Okay, so have a look. dy by dm upon dx by dm. So difficult, na sir? This step can also be avoided to be written. Differentiate now. Derivative of this will be m times of e power m minus e power, again will come m, right? 1 second. Minus m times of e power minus m divided by, 1 second before I move on, If you ask to differentiate this term, what is the answer going to be? Derivative of this will become same thing, and differentiate this by chain rule, we get here minus m. We get here, sorry, minus 1, right? We get here minus 1, excuse me, my bad. M is the variable, right, not a constant. So we get here minus 1. This is a mistake that I made. I'm going to change that. M is the variable, right, so we will not get this value. We'll get simply minus and plus. Okay. And there's a number divided by 2, I think, over here. Let's keep that as it is. Let's keep that as it is, okay. And let's move on to differentiate x now. So for x we'll have over here, please check. So for this we'll have e power m as it is, and again we'll get what? We'll have here minus of minus 1 e power minus m. Divided by 2 is there, we can cancel, but don't cancel because we are looking for in terms of x and y only, okay. And we want that to be divided by 2 to get the value of x and y, okay. So we get dy by dx, one last step over here, as this will be what? Have a look. This is nothing but e power m minus e power minus m by 2. That's my x value. Yes, I differentiated y, but I'm getting what? This is my x value. Please check. E power m minus m by 2. So I'm going to write this as simply x. Numerator is x. Now denominator, e power m minus and minus will be what? Plus. Will be what? Plus. Okay. So I get e power m plus e power minus m. Okay. So I get this as y, and that's my answer. That's my answer. Okay. So question will be what? Option A is correct. Option A is correct. This is it. Have a look. This is again a two-step question. You need to write this step and this step. That's more than enough. Okay. That's more than enough. Two step. If you want, you can solve in one step also. Just writing this step and getting the option as option A. Alright, question number 3 is done. Question number 4 now. Can you solve question number 4? Okay, so this is clear, right? This is clear, no? Okay, let's move on to question number 4. Another question where I have to differentiate a function with respect to another function. Okay, so basically the second form of parametric form of derivatives. Here, check this out. Tan inverse of x we have, here we have cos inverse of sin x. Cos inverse of sin x. Let's solve this question. I'm going to take this as again y as cos inverse of sin x and t as tan inverse of x. Tan inverse of x. I'm going to show you how to do it, but you have to give me an option for this. So it will be a homework. It will be a homework. Comment and give me the correct option. Okay. So I'm looking for dy by dt will be what? Dy by dx upon dx. Sorry, dt by dx, right? 1 second. This will be dt by dx. This will be dt by dx. All right. So differentiate this. Cos inverse derivative is what? 1 upon 1 minus 1 upon 1 minus sin square x in the root. Correct or not? Derivative of cos inverse of something. Minus 1 upon whatever is the root of that. 1 minus x sin square of that value. 1 minus sin square of that value. That basically our value is sin x over here. So square of that value, which is sin square x. Now is it over? No. Apply chain rule. So cos inverse is done. I have to apply for sin x. We get the answer as cos x. Okay. Cos x. Divided by derivative of tan inverse of x. Answer coming as 1 upon 1 plus x square. From here, please simplify and give me the answer which option is correct. Question number 4, give me the answer which option is correct. Right now, you give me. Okay. Question number 5 now. So question number 5 now, but please give me answer for the question number 4. Please give me answer for the question number 4 in the comment section. Now this here is a very beautiful question. If you go ahead and write the derivative in the form of sin inverse and cos inverse, it will become very tricky and difficult, calculative and all of that. But if you use over here a simple substitution, then this question becomes very, very simple. Very, very easy. How do you do that? Please check. We are getting here 1 plus t square in the root. This becomes very simple if you take t as tan theta. Take t as tan theta. How come, sir? So this will be what? 1 plus tan square theta. That will be what? Root of sec square theta So let's say I take only positive value, first quadrant, so sec theta. Sec theta. Basically, 1 plus t square is what? Sec theta. Now you check. So value of y will become what? Cos inverse of 1 upon sec theta. What we have? Cos inverse of cos theta. So what we have? Simply theta. That's the value of y. Y value is what? Simply theta. Okay. Moving on for x. So we have x as sine inverse of, this is going to be tan, right? So tan theta divided by, again, sec theta. Okay. Simplify now. Sine inverse of sine theta upon cos theta and 1 upon cos theta. Cos cancelled, I guess. Sine inverse of sine theta. Answer is simply theta. That's my value of x. X value is theta, y value is also theta. I'm looking for dy by dx, right? I'm looking for dy by dx. Excuse me. I'm looking for dy by dx. Answer is what? Dy by d theta upon dx by d theta. Derivative of theta with theta is what? Is 1. This is theta, right? Y is theta. So 1 upon 1, answer is simply 1. Answer is simply 1. Please check. Answer is simply 1. Have a look. This is 1, okay? Question is over. So answer is simply 1. Alright, so fifth one was very simple. If you use a substitution of this is very important substitution, okay? Substitution is very important over here. Very much important substitution. Please have a look. Fifth one is over. Question number 6 now. This is clear. I hope none of you are trying to solve it like this, inverse formula of sine inverse derivative, cos inverse derivative. Don't use that approach. It will lengthy. You can use this one. It's faster. Again, if you are asking me the number of steps we can use to solve this question. So this is the important step, of course. One step you have to do this one. One step. Then you can do this step. You can do directly, I think this step will be enough. This step. And from here you get this step, and that's all. So 1, 2, 3, 4 step question. 4 step question is this. No need to write all of this thing if this comes as a MCQ in your CET or PU2. Okay. Like this question will not come in JEE mains, you know that very well. So, but yeah, in PU2 and in boards, questions like that can come. So you can solve it using these 4 steps. If it is just your CET, just to process the faster steps, and if it is the boards, you have to do all the steps, which is very much important for your marking scheme. Question number 6. If e power y times of x plus 1 equals to 1, then so that derivative of, okay, second derivative equals to first derivative whole square. Second derivative equals to first derivative the whole square. Okay. Okay. Write e power y as x plus 1. Sorry. My mistake, sir. My mistake, sir. 1 upon x plus 1. Okay. So we have, I'm taking this x plus y on this side. Okay. It will become 1 upon x plus 1. Next is what? Apply log on both sides. Apply ln of e power y and ln of 1 upon x plus 1. Okay. Which can be written as what? Can be written as ln of x plus 1 power minus 1, right? In the index form I can write, so that this minus 1 can come in front of the log. Again this y will come in front of the log. I get y ln e equals to minus ln x plus 1 minus ln x plus 1. Ln is what? Ln e is simply 1. Log of e with the base e is 1. Differentiate this, we'll have y dash over here. This equals to the derivative of this. So I get 1 upon x plus 1. 1 upon x plus 1. That's my derivative of ln x plus 1. This is my first derivative. Y dash means first derivative. I'm trying to find out now second derivative. Y double dash will become what? Simply derivative of this part. You have minus sign outside. Derivative of this will be what? Again we'll get minus 1 upon x plus 1 the whole square. I'm getting here plus 1 x plus 1 the whole square. Now tell me, this is y double dash. Can I not write this as this the whole square minus 1 upon x plus 1 the whole square? I can do that. So basically I am getting this as y double dash equals to y dash whole square. Y double dash means second derivative, y dash means first derivative. Please check. I am getting y double dash as 1 upon x plus 1 the whole square, and y dash is what? Minus 1 upon x plus 1 the whole square. I am writing this value as minus 1 upon x plus 1 the whole square. I can do that. I can do that. Okay. I am getting y double dash as y1 or y dash the whole square. Y dash the whole square. Please check. This is clear. Question number 6 is clear or not? Yeah. Question number 7 now. Second derivative of this function. Very difficult? Very difficult? Of course not, sir. How do you solve this? Y dash will be given by derivative of first log. I get 1 upon log x, and derivative of this log now, so 1 upon x. So what I get? Y dash is nothing but 1 upon x log x. 1 upon x log x. Second one, y double dash will be given by derivative of this in the quotient form. In the quotient form, okay. Differentiate 1, we get 0, write 0 minus. Differentiate this. Derivative of x will become what? I have to differentiate the denominator, right? So use what? Product rule, for because we have two functions here. X log x, use the product rule. I get x as 1, so 1 times of log will be log x. What I have done? I have done differentiation of x, which is coming as 1, so log x, plus will be there, and we get derivative of x as it is, and derivative of log will be 1 by x. So x is as it is, and derivative of log will be 1 by x. My mistake. Okay. Divide by the denominator the whole square, so I get x log x the whole square. Simplify now. I am getting here y double dash equals to minus, 1 second, it is 1 actually. It is 1 plus log x divided by x log x the whole square. That's the final answer. 7th is also done. Question number 7 is also over. Question number 8 now. Question number 8. They are asking you to prove that second derivative of the given function y, second derivative of given function y equals to 49y. 49y. Okay. Shall I give you this homework? Can this be homework? Very simple question. Alright, I'll solve it for you anyway. So I can write y dash of first derivative as, check here, the number 500 I'll keep as it is. 500 e power 7x I'll keep as it is. Because e power 7x will remain as e power 7x, but you have to differentiate 7x also. For that you're going to get what? 7 over here. I'm keeping that outside. You'll see. Over here also again I'll get what? Minus 7 will be there, 600 as it is, and e power minus 7x. But I'm asking you to what? Remove this minus 7 from here and keep it outside. Because we had 7 over here and we had minus 7 over there. I'm taking the 7 common from both the terms. So this will be basically like this. This 7 is again taken common, this also is taken common. That's the first derivative. This is my first derivative. Okay. Second derivative will be the same thing. Please check. This 7 was there. Differentiate one more time, you get what? 500 e power 7x. Derivative of 7 one more time, we'll get what? Into 7 minus 600 as it is. I get e power minus 7x. Derivative of minus 7x will be what? Again minus 7. Now we take this 7 and this 7 outside. What I get? 7 was there, I'm taking 1 7 again outside. So 500 e power 7x, and this minus will make plus. Okay. So plus 600 e power minus 7x. So I get the answer as 49, and check this carefully, this is nothing but a value of the function y. The 49y is the value of second derivative y double dash. Y double dash. Very simple, 49y. Proved, sir. Question number 8 is also over. Question number 8 is also over. Question number 9 now. Okay. Now, so if you actually, so what are they asking you? They have given a function to you in the implicit form. So they have given an equation actually, ax square plus 2hxy plus by square equals to 0, and they are asking you second derivative of y. They're asking you second derivative of y, basically y double dash. All right. Now one more thing, please check over here. They're asking you, the options which is given to you are constants. It means things has to be cancelled somewhere. All right. Now apart from that, now how do we process this question? As a student, what I think, so of course sir, my one approach is very simple. Differentiate this whole thing, get the value of y dash, take y dash as subject, differentiate again, you'll get the answer. Okay, but won't that be too challenging? One step, if you have too much time, find, differentiate all of this, then make the subject as y dash, something will come, differentiate again, this will be coming as one of the options. This approach is correct, you're going to get the answer, but it will be too long, too much time taking, and might be chances of making mistakes. Okay, what next then? Then as a student I can go ahead and think that this is going to be what, dear? This is going to be, can I make a perfect square over here? Answer is no. We have ax square, we have 2hxy, we can't make perfect square also. Now next approach will be what? Okay, we'll see what happens later, but right now we can find first derivative. That much I have to do anyway. Let's do that. Find first derivative. So what I get, it'll become a twice of x, right? And this will be what? 2h is a constant. For x I'll have 1, so simply y, and for this I'll have x y dash, okay? And over here I'll have plus 2b y dash equals to 0. Have a look. Derivative of y square is 2y, and derivative of y is going to be y dash. Now separate the terms from here. So you can see I can actually, over here I have 2ax plus 2hy, and in the y dash if you take common, you're getting what? You're getting over here 2hx, okay, and over here we have 2by equal to 0. Alright, now let's see something, we'll try to make the subject as y dash. So I get y dash equals to, take this terms over here, I get minus 2, I can take common, so I get ax plus hy divided by c. I'm taking these two terms on this side, okay. So I get ax plus hy, minus 2 is taken outside, divided by this, 2 times of hx plus by, 2 and 2 is cancelled. So I'm getting y dash as simply, I can erase this, don't need to write another time. I can simply erase this, right, minus 2 and this, okay. That's my answer for y dash. This is my answer for y dash. Now what next? Have a look. So if I can get a relation between, x and y, I'll tell you. Check here, we have ax square, we have hxy, but twice of that is there. Let me break this once for you. Right here, ax square plus hxy, right, and plus hxy plus by square equal to 0. Check this out. I can make a relation between x and y over here by use of the factors. I can take what common? I can take here x is common, so I get here ax plus hy. See, we're getting this numerator over here. Means something can be substituted on this side. Again, I can take y common over here. I get hx plus by. Have a look. Hx plus by. Now I'm very sure that something can be done about this. So I want to find what value of y. I want to keep this in denominator, right? So I'll keep it as it is. I'll get y times of hx plus by. Please cross check. I want to keep this in the denominator. So I'm going to keep this together as a multiplication and move the other term, this term, over this other side. So I get here minus x times of what we have, ax plus hy, okay. Now right here, move this x on this side, I get y by x equals to minus ax plus hy divided by hx plus by. Have a look. I'm getting y by x. X comes over here, so y by x. This is ax plus hy, and this is hx plus by comes over here. Clear or not? Have a look. Yes. So is this the same thing? Ax plus hy and hx plus by with a minus sign. It means I can write from here, this is my equation number 1. If I say equation number 2. So use 2 in 1. So I get this value as y dash equals to actually y by x. Y dash equals to y by x. So I hope you got it. What I've done, I have found the first derivative. Then I use the equation which is given to us to find the expression in terms of y and x, and that came out exactly as derivative. So I'm writing y dash as y by x. Now is it easy to find second derivative from here or not? Can we find second derivative from here or not? Of course. Use the quotient rule. Y double dash equals to derivative of y will become y dash, okay, and we'll have over here x as it is, minus derivative of x will become what? Simply 1, and we have y as it is, right, divided by x square, okay, divided by x square. Please check. Now y dash is what? What is the value of y dash? Same again, y by x. So right here, y by x into x minus y upon x square. X and x is cancelled. I get this value as 0. 0 by x square, right? So answer is coming out as 0. Have a look. Derivative of, I'm doing the quotient rule over here. So derivative of y will be y dash x as it is minus sign. Derivative of x is 1. Derivative of y will be as it is. Okay. And y dash is what? This y dash is nothing but same thing, y by x. So I'm using this y dash as y by x. X is cancelled. I get y minus y. Answer is what? 0 by x square, which is 0. So option going to be A. If you solve this question using the method of differentiate this one, it'll take too much time. You'll have a lot of chances of making mistake. You can again differentiate this to find the y double dash. You can use the simple method of finding the y double dash from here also. You get the same answer, but it'll take too much time and you'll make a mistake also. But if you use this expression given to you, this equation given to you to get a relation of x and y, then it becomes very, very simple. Then it becomes very, very simple. So this is a very unique question. Okay, but can be asked in the CET. Can be asked in the CET. Okay. For this question, you have to do some steps over here. I'll show you. So you have to do this step. Of course, this step is required. This step is also required, and this step is also required. 3 steps so far, and what? This step is also required. 4 steps. This is not required. This step is like 5 steps. 5 steps is enough to do this question. Again, 5 steps. Rest all can be done in your mind. This is a 5-step problem. If it comes, it will be on the challenging side. It will not be an easy question, okay? Because it is again based upon application of implicit function in the second derivative. This is what? Second derivative, and this is what? Implicit function. There is no way to find the subject y. Even y dash also, you have to put effort to find y dash, okay? This is the implicit function application in the second order derivative. I hope you like this question. Let me know how many of you enjoyed this question number 9. Did you like this question number 9 or not? Let me know in the comment section. Okay. If you want the question to be of this level only, if you want the question to be of difficult level only, let me know that as well. You want questions to be solved in the session like this question number 9. Okay. Question number 10, which is the last question of the day. Let's solve and complete our session today. Last question of the day. Okay. I'm going to use over here properties of log. Properties of log. How come, sir? How come? Because we have power in the given function. Whenever you have power, product, quotient, you try to go for what? Try to go for applying log on both sides. Yes. Have a look. So take here log y equals to log of x power minus x, which gives me what? Minus x times of log x. That's my log y. Okay. Now next is differentiate. Next is differentiate. What are you going to get for this? You'll have 1 by y over here, and y dash equals to derivative of this will be what? You'll have simply log x over here and plus x as it is. Derivative of log is what? 1 by x. I get x and x is cancelled. That's it. So I'm getting over here this as minus 1 plus log x is the value of, okay, not this. Of course, we'll have to multiply this with y also there. 1 second. 1 second. So this will become what? Y dash equals to minus y times of this. I'm moving this y over here, right? So minus y times of 1 plus log x is my y dash value. This is the value of my first derivative. I'm looking for second derivative. I'm looking for second derivative. So we're going to solve it over here. All right. Second derivative now. Same thing. we have to apply what? Product rule. We have to apply here product rule. So check his. My sign is outside. Differentiate y now. We get y dash. Keep this as it is, 1 plus log x. Okay. And this time keep y as it is. Keep y as it is. And write this as a derivative of 1 plus log. So 1 plus 1 by x. Is it right? Sorry, not 1. Not 1. Excuse me. My bad. Simply 1 by x, right? Because you have already taken that derivative of 1 as 0. So I'm taking derivative of 1 plus log x. 1 will become 0, log x will be 1 by x. So y times of 1 by x. Substitute the values that you have now. Minus is outside. Y dash is how much? This. So minus y times of 1 plus log x times of 1 plus log x, okay, and plus y upon x. Okay, I'm putting this value over here in place of y dash. Alright, so you can see this is a whole square over here. I'm getting the answer as, I can take y common. This is going to be, I'm taking minus y common actually. So it will become plus y, and over here we'll have what? 1 plus log x the whole square. And this will become minus 1 by x. Okay, minus 1 by x. Please check. What I've done is I've taken minus y common. So this minus y with minus becomes plus y. This plus will become minus because I'm taking the minus sign also common over here. My final answer, one last time, please check. Y double dash equals to, y's value is what? X power minus x. X power minus x times of, we have 1 plus ln x the whole square minus 1 by x. That's your final answer. Please check. So which option is correct? Option B, I think. X power minus x, 1 plus log x the whole square minus x. Minus 1 by x. So option B is correct. Option B is correct. Please check. Option B is the correct option. Again, a very beautiful question. Okay. So I hope this was fun session. I hope you enjoyed this session. Okay. So go ahead, join the WhatsApp channel to download the class notes, and from there practice these questions again. All these are of the difficulty level to the exams, criteria. Means question can be asked like this in the examination. So very important for all of you to solve this 10 questions. And again, if you want me to solve more questions, let me know in the comment section again. Whatever is your requirement, you have to tell me in the comment section only. Okay. So I'll meet you again very soon. Till then, keep working hard, keep smiling. Take care. Bye bye.